Hello. Today we're going to look at more advanced forms of our trigonometric function graphs. So before we've looked at simple y is equal to sine, y is equal to cosine, y is equal to tan functions. Now we're going to look at what happens when we modify these functions, when we multiply sine by things or add numbers on and so forth. To do that, we need to discuss a little bit of language first. So first one we've already talked about is the range. That's just the highest to the lowest y value. Same thing range has meant for a long time, the highest to the lowest. And we've already looked at how our range is written and how it works. So our normal range for our sine and cosine functions is +1 to -1. But we can modify that if we have a more complex function involving sine and cosine. The middle line or midline is a horizontal line. It's a dashed line that I have drawn in here, and it's effectively the line that our function oscillates around. So you can imagine if these were waves in water, the midline would be the level of the still water before we splashed it, before we made it oscillate or wave up and down. So this is the level of the still water. This is what our wave oscillates around. It's kind of our neutral line. And in practice, it's halfway between our peaks and our troughs, the halfway between our maximum and minimum heights. So we'd find halfway between our max and min value to find the y is equal to for the equation of our midline. Amplitude is a name for how big a wave is. So amplitude is connected to the power in a wave. If it is a large wave, it has a lot of power in it, which we might come across in physics. And in practice, it's the difference between the neutral line, the midline, and the maximum or minimum. So we could also have the amplitude going down to here. So the distance from the midline down to the minimum, or the distance from the midline up to the maximum. And finally, we have the period that we've already talked about. The period is how far we go along in the angle direction or in the x direction before we start repeating the function. So this function is a periodic function. It will keep going past the period that I have drawn here. It would keep going as I can see that this is a sine wave because it starts off at 0 and rises up and then goes down. So if it starts at 0, it's going to be, if it starts at the midline, I should say, or starts at a neutral midpoint, then it's going to be a sine function, and we've looked at why that is, why sine starts that way, because it's the y coordinate in our unit circle. Just like a cosine function, I may as well tell you this is a cosine function because it's starting at its maximum and then it's dropping towards its midline. So this is what a sine function looks like in general. This is what a cosine function looks like in general. So that's our amplitude, our period, and we know that without any modification, the period of a sine and cosine function is going to be 2 pi, and the period of a tan function would be pi, or 180 degrees. So the period of sine and cosine functions is 2 pi, or 360 degrees, and the period of our tan function is pi, or 180 degrees. And we need to have those facts in the back of our minds as part of our toolkit for doing these problems, because exam questions based on this stuff actually get fairly involved and require a certain amount of interpretation and creativity. Now, let's have a look at the general form of a sine or a cosine function. So y is equal to some constant a. So a is just a number, b is just a number, c is just a number, x is our variable. So y is equal to some number plus b multiplied by our function. This could give you a cosine or a sine function. And in the brackets, we have a number multiplied by our x input, which would often be our theta input. Now, a is the number that we are oscillating around. So y is equal to a would be the equation of our midline. So y equals a would be our equation of our midline, because this is the part that's oscillating and this is the constant. So it makes sense that when We don't have an a written there when a would be 0. We're oscillating around the x-axis when y would be 0. So our a, our constant at the beginning, would be our equation of our midline. Our amplitude is the size of, or the magnitude of, the b here, because we know sine or cosine is going to oscillate between +1 and -1. And then if we have an amplitude that's bigger than 1, it's because we have multiplied our oscillating function by some constant b. Now, this is a formula for the range. You never actually need this formula. You can always work it out from a diagram, and because of the way the exams work, I recommend that you do. But this is a formula you can memorize. It is not in the log tables. None of this actually is in the log tables. But if you feel more comfortable memorizing formulas, this is a formula for getting the range of your function if you figure out a and b. But you will always be able to figure out the range based on that information by telling yourself the story. Likewise, this is a formula for the period of the function. If c is the number that is multiplied by your theta, your input variable into your sine or cosine, then your period is going to be 2 pi divided by c, or 360 divided by c, depending on whether you're working in radians or degrees. Now, this is an awful lot of introductory stuff. Let's actually do a question and put this into practice. If y is equal to, so this is our function, just like we'd have a quadratic or a cubic function, this is a function. Y is equal to 1 plus 5 times cos of 4x. What is the period and what is the range? Well, if I ignored the cosine, the oscillating part of this, for just a minute, and I had y is equal to 1, this means that my neutral point, my thing that I am oscillating around, is y is equal to 1. So my midline, I was to draw in a very quick sketch of this, my midline is going to be at y is equal to 1. This is the type of sketch I can draw in to give myself an anchor for what's going on. I know I'm dealing with a cosine function, and I know that my cosine is going to have a maximum of 1. So if I just think about the cosine part of this, this is going to oscillate between plus and minus 1. Its range is -1 to +1. Now, when it's at its maximum, this varying part will be at 1. So my y will be 1 plus 5 times 1, which is 6. So the top of this function is going to go at 6. And then the bottom of it will be when this is down at -1. So I'll have y is equal to 1 minus 5 is going to be down at -4. So we can see how it is we can construct. You can draw this more accurately than me in your ruled books or in your ruled exam papers. And I know that I have a cosine function, so I'm going to start off at my maximum, then drop down and come back up again. I'm going to have this general pattern for a cosine function as opposed to a sine that starts at 0 and then rises. So roughly speaking then, my cosine function is going to look something like that. Not my best cosine function that I have ever drawn, but it gives me a rough notion as to what I'm dealing with. So this is going to be my end of my period coming down here. Now, what would my period be? I'm going to give you an argument for this, and we're also going to use the formula. The period is how long it takes to go through 360 degrees effectively. That's what the period of our normal function would be. So that's going to be, normally that would be 360 degrees if we were working in degrees. But here, I'm multiplying my x inputs, my theta values, my angle values by 4. So if I think about different values of angle that I could put in, if I put in theta was, or x was 30 degrees, I'd end up with the angle inside here effectively being 4 times 30 is 120. So I'm increasing my angle 4 times quicker than I usually would. So if I go up to x is 90 degrees, I'd have 90 multiplied by 4, which gives me 360. So actually that tells me then that by reasoning it out, I'm going 4 times faster. So my full period is going to be when I go through 90 degrees, or if I prefer, pi over 2 radians. Now, how can we do that with a formula? Because we can do it with a formula. We'll say we'll take our period in degrees. Our period would be equal to 360 divided by whatever number is multiplying our input, and you'd get 90 degrees. So you can just use the formula that we discussed before. You can also reason it out. Now, what's the range of this function? Now, because I've drawn this in, because I argued it out, I already know what the range is. I'm going from -4 up to 6. I'm going plus or minus 5 above and below my neutral line, my midline. And you can argue it out that way, or you can learn off this formula and sub into it. That the number by itself minus the magnitude of this gives you your lowest value, and this number plus the magnitude of this gives you your maximum number. You can learn that off, or you can get good at drawing your sketches. From an exam's point of view, the sketches have been better because they lead more into what the examiners are looking for in terms of skills you have to apply. Now, let's go the other way. In this case, we're given a picture and we want to try and form this general equation. Well, let's see if we can build ourselves up to it. Our range is something that we can fairly immediately see, and we can also see, as I already mentioned, that we have a cosine function. How do I know? Because it's starting at its maximum and then it's dropping down and then going back up. So when theta is 0, we're at our maximum. So that tells me I have a cosine type function. So I immediately know I have y is equal to a plus b cos c, and I'll put in theta this time. I already know from the shape of the function that that's what I'm talking about. Now, what else do I need to know? Well, I want to know my period. Sure, we can start with the period. When I look at my full period, I know that this is the general shape. From here to here is where my function starts to repeat itself. So this is one full period. From 0 to pi is one full period. So I can use my formula, or I can reason it out. If it takes me from 0 to pi to go through a full period for a cosine function, and it should take 2 pi, that means that I am going twice as fast as I should under normal circumstances. Therefore, my value for c must be 2, because I'm going through a period twice as fast as I would expect to. However, if I know the period is pi, and I'm dealing with radians this time, so I'm going to deal in radians, I can put my period is equal to pi is equal to 2 pi all over c. Rearranging this formula, you'll get that c is equal to 2. I leave it that you are able to rearrange that. So we know c is 2 either by arguing it out or by using our formula. Now we need to know the value of a and b. So a and b we get effectively from the range. So what's our range here? We are going from -1 up to 5. Well, the middle line is going to be halfway between those 2 points, which is going to be at 2. So our middle line is at 2. So a is 2, and from our middle line up to our maximum or our minimum is 3. So b is equal to 3. So this is our